to do? Because I definitely can do it. This is just me making literal jokes. Like, can you do it? Of course I can. Next question. Get it? Ha 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 ha. All right. So, first thing I do when I look at problem like number 8 is I recognize it's not a proportion, so I cannot cross multiply. What I'd want to do is start by clearing fractions. Before I can clear fractions, I have to make sure I've factored. There's one piece in here that can factor. The x squared minus 3. I can take out a greatest common factor of x. Now that I have everything factored, I can identify my least common denominator, which is just going to be x times x minus 3. Right? Those are the only two primes or prime terms in the denominators. So I'll multiply both sides by that least common denominator. And then we'll distribute that through. Lily, so far so good? Okay. So now we'll reduce. So I'm left with 18 from the first fraction minus 6x from the second fraction equals 5 times x minus 3. So far so good? Okay. I'm going to distribute through that 5. And then I'm going to say add 6x to both sides to give me 11x, and then add 15 to both sides to get me 33. If I divide both sides by 11, I get 3. But I'm not done. Remember, I have to check my answer. And I notice that if I say I plug that 3 into this denominator, it does give me 0, right? Any denominator, if it happens in any denominator, if it gives you a 0 in any denominator, it's a problem. So I discard it, and since I don't have any other solutions left, I just have to write no solution. Is that okay? Cool. Who else got some?
Mr. Kulik.
Yes, sir.
Can you do number 3 on homework 4, please?
Sure. This was the trickiest one on homework 4. So not surprising that we want to talk about it. And what's tricky about it is the form that this problem is written in isn't either of the two forms that we talked about, right? So there's kind of two different things you could do here. So one thing you could do is you could make a common denominator with the 2 over 3x plus 3 and the negative 2 and add those two fractions together to put it into form 2. Or what I think is maybe a little bit easier but a little bit sneakier is you can take this and put it into form 1. So you can start by factoring the 3 out from the denominator. And then if you divide the top and bottom of that fraction by 3, you have something that's in form 1. So there I can see that the h is -1 and the k is -2. But Enzo, really, even easier than that is for these simple rational functions, regardless of the form, the vertical asymptote is really just when the denominator is equal to 0. So even if this wasn't in form 1 or form 2, or you forgot the formulas on how to find them in form 1 or form 2, you can just take the denominator, set it equal to 0, and solve, and that'll give you your vertical asymptote as well. So that's, I guess, 3 ways you could have gone about handling that. Is that okay, Enzo? Okay. So we have our vertical and horizontal asymptotes, and our domain is everything except for the vertical, and our range except for the horizontal. And then I'll fill in my table here. And I'm just going to go ahead and do this with my mental math here. So if I plug -4 in, I get -9, or 2 over -9 minus 2. So that's like 2 and, or -2 and 2/9, which is -2.2 repeating. And then that's going to be -2/3. So -2 and 2/3 is -2.6 repeating. And then -2 is going to give me, oops, sorry, that's 1/3. This is -2 and 2/3. Again, I'm just kind of like plugging this in. So that's -1 and 1/3. And that's going to be -1 and 2/3. And then my last one is -1 and 7/9. Again, feel free to use your graphing calculator or whatever to compute those fractions. If you're not good at fraction mental math, which totally not an expectation that you're doing fraction mental math, certainly as quickly as I am. I mean, I have a lot of practice doing stuff like this, so use your calculator. Even if you feel like you're good at it and you're like, I'm going to just double check that anyways, like totally reasonable thing to do. If I was answer key or whatever, I would probably also, just to be sure that my brain didn't run out my ears or something. Okay, so let's go ahead and plot stuff. So I have -4 and then -2.2, maybe about there. And then -3 and -2.3 is maybe like there. And then -2 and -2.6 is maybe like there. These are kind of squished close together, so it's tough to get a great picture out of that, but that's not terrible what we just did there. So 0, -1.3, 1, -1.6, and 2, -1.7. And so we'll draw the graph again. And there's that piece. Happy with that, ends? Okay, cool. What else? Do you guys want to talk about some more? Happy to do more if you want to. If you're fine, like, that's cool too. No big deal either way. Ave?
Could you do number 5?
Sure. So this is an example of a problem kind of in that form 2. I remember in form 2, my vertical asymptote is negative d over c. So my c in this case is 4, and my d is negative 3. So negative 3 over 4, the decimal 0.75. Since I'm going to be graphing all this stuff anyways, it's probably more convenient to have it as a fraction or as a decimal than a fraction. You could certainly leave it as a fraction, but it's just kind of a hassle. The horizontal asymptote is a over c, so the a in this case is 2. The horizontal asymptote is 5. And so my domain is everything except the vertical asymptote, and my range is everything except for the horizontal asymptote. So I'll put my vertical asymptote in the middle, and I'll pick some values bigger and smaller than it. And then I'll just kind of plug these x's in to get their respective y's. Let's see, that's going to give me 1 over negative 11, negative 0.1. I'm just going to round these to the nearest tenth because it's about all the accuracy I can really get out of something like this. See, if I put the negative 1 in there, I have 3 over negative 7. So I think that's like 0.42 and change, but I'll just call it 0.4 since I mean, that's a repeating decimal, but it's like 7 numbers that repeat, so I'm not going to write it all out with the little bar over it because it's just a hassle. And I think the 11 is like 0.9 repeating. I can't remember though for sure, but I'm just going to round it to 0.1 there. I put the 0 in, that's 5 over negative 3, so that's just negative 1.6. The 1 in is 7 over 1, so that's just 7. Then we have 9 over 5, which is 1.8. And then we have 11 over 9, which is 1 or 1.2 repeating. So we'll put in our, is that positive? Oh yeah, okay. So there's positive 1/2. And then negative 0.75 is about there. A little bit more than halfway. And then let's start plotting. So negative 2 and negative 0.1, maybe there. Negative 1 and negative 0.4, maybe there. 0 and negative 1.6 is about there. There's that. Cool so far? Okay. Again, if I'm doing something you don't like or understand, or I went too fast or something or whatever, stop me and holler. No big deal. So 1, 7 is off my graph somewhere. I guess I'll just like stick it up there because that looks like eyeballed about where 7 would be. I'm not really going to attach that though because it's just too far away. And then I have 2 and 1.8, and then 3 and 1.2. So my expectation here is if you have something that's like way off the graph like that, like you can connect table. I'll be pretty reasonable about that if you end up finding something that's like way off or something. Like you don't have to find a new point. It doesn't mean you did anything wrong. It just means that like you pick something that maybe I didn't expect. And in fact, I end up picking something that maybe when I did this problem myself and making sure the numbers worked out okay, I probably did 2, 3, and 4 on the right side and skipped 1. And that's why I didn't think that I didn't make a bigger, make the numbers bigger on the graph or whatever. And I thought that would be fine. So I probably did the same thing. Or I ran into the same thing. I picked a number that maybe I wasn't expecting. But whatever, you know, not a big deal. I'll be pretty forgiving on that kind of stuff as long as the shape is correct and the numbers, like the points are actual points, you know, if they don't actually fit. But your picture is correct, that's fine, you know. We kind of know what these things are going to look like anyways, right? Cool. You happy then, Aves? Okay. Anybody else? Again, happy to do more if you want to do more. If you don't, that's cool too, no big deal. Kind of feels like we're at a stopping point, which is fine. You'll see in the content library, I've posted the review. The test format will be almost identical to the review, just shorter. Again, you guys have seen that with the Chapter 5 review, right? The test and the review are quite similar, just the length on the test is a little bit shorter, but the question formats are all the same. So the review, we have 2 reducing problems. I have 3 multiplication and division problems. I have 3 adding and subtracting problems. And then I have 2 multiplication, division, and addition, subtraction problems where we're combining the difference or the different operations there. And then I have 5 solving, and then I have 2 graphing problems, but the format will be the same, the questions the same way, be approximate the same level of difficulty. Now I've put in the key for the review as well. Again, because I'm not sure that we'll get a chance to test, so I have a key with like worked out solutions on kind of what I did. As always, like it's possible that I've made mistakes in here.